door, you can have it, but you should have gotten it during passing period. Huh? Usually someone with the erasers. I don't think there are any left, but you can grab a yellow marker if you want. We'll do kind of the same thing. Okay, notes number 1. Starting with states of matter. First thing you need to highlight is the definition of matter. Matter is anything that has mass and takes up space. Anything that has mass and takes up space. Second, you're going to want to highlight the definition for physical property. Physical properties are anything you can observe or describe about the object. Okay? So Brian, definition for matter, definition for physical property. All right, below that, highlight the definition for the 4 states of matter. I think your spacing is a little different than mine. Solid, a state of matter in which the matter has a definite volume and shape. Liquid, a state of matter in which the matter has a definite volume but does not have a definite shape. Again, I think yours is spaced differently, so you're probably already on the back. And then also the definitions for gas and plasma. Gas, a state of matter with no definite volume or shape. Plasma, very much like a gas, but with free electrons. Yes.
So, we did that before, but so is fire simply gas, liquid?
Fire creates a gas. The actual flame is energy, though, I believe. Correct. I don't believe so. The only one I could think of would be plasma, but I think it's actually energy. Really no.
So energy
Energy is the only thing that is not matter. Okay? All right. For the next page, changing states / phases. To change phases, you have to add or take away energy. Go ahead and highlight that. Change phases, you have to add or take away energy. And then at the bottom, I want you to know the 3 different atom models. Solid, liquid, and gas. You will have to be able to label those for the, I think the quiz, but I know the test. I'm almost positive. Test. Okay? All right, then you can go on to notes number 2. Okay? First thing I want you to highlight is the definition for mass. The measure of the amount of matter an object contains. The measure of the amount of matter an object contains. Next, I want you to highlight ductility and its definition. I want you to write duct tape out to the side. That's your kind of clue to help you remember what ductility means. The ability to be pulled into a thin strand like a wire, just like tape. You good? Oh. Aiden? Why? So you didn't highlight that page? Okay, once we finish this, I can give you the notes copy. Okay, just remind me. Below ductility, I want you to highlight malleability. You're also going to write your keyword off the side there. This one is molded. Remember the M and the M. Malleability means can it be molded? Come on, Jacob. The ability to be pressed or pounded into a thin sheet. And again, make sure you write molded out to the side. Next, the definition for solubility. The ability to dissolve in another substance. Solubility, will it dissolve? Make sure you're with me. Okay. Then below that, all four terms. Dissolve, solution, solute, and solvent. Dissolve, solution, solute, and solvent. Okay, turn to the back. You also highlight the definition for melting point. When something turns from a solid into a liquid, and you also need to know the temperatures of that for water. For water, it's 0 degrees Celsius and 32 degrees Fahrenheit. Then also the boiling point, temperature at which it changes from a liquid to a gas, and then those temperatures as well. 100 degrees Celsius, 212 degrees Fahrenheit. Yes. Jacob?
I thought 32 degrees Fahrenheit would freeze.
Depending on which way you're going. If you're heating it up, it will melt at that temperature. If it's already a liquid and you're cooling it down, it will freeze at that temperature.
Oh, so for heat.
No, for each way, it's that same temperature point. But if you're going from a solid to a liquid, it's called the melting point. If you're going the other way and you want to go from liquid to a solid, it's the same point. It's just called the freezing point then. Brian?
What if it's under 0 degrees Celsius? What is it called?
Still a solid.
Like, what is it called?
What would you call that temperature? It wouldn't be called anything. It's not like a benchmark point for that substance. Okay? Alright, notes number 3. Highlight the first two. Density, the amount of matter in a given volume, and relative density. Floating or sinking when compared to water. Greater density than water will sink. Less density than water will float. Okay? Relative density is very similar to density. It just specifically has to do with what is its density related to water. Okay? Below that, highlight the box, Jacob, where you have the equation for density. You should have it written both ways, D equals M over V, as well as D equals M divided by V. I also want you to write above that or near it somewhere. You're going to have to use this in a word problem. I'm going to show you how to do that here in a minute. So, it will be exactly like we have right below the box, where I had you rewrite that word problem and then we had to solve it. Okay? However, when you solve it for the quiz or the test, I want you to use the same 3 steps. The first step is where we rewrote the equation. The second step is where you rewrite it again, but plug in the numbers you know. The third step is where you solve it. It's on the back side. Sorry. The spacing's off again. Yours is on the back side. It's right below where you wrote this problem. You can if you want to. You I want you to know that you have to do something like that on the assessment. Layla? Right, because mine's spaced out differently. The actual word problem here? This. This. Oh, it's only because I did M over V instead of M divided by V. Okay, well then it should look like this. What do you have that's different? Yeah. Brooklyn? Because we haven't gotten to that part yet. Yeah, so you have G equals M over V. Oh, well first you need to erase this and put a D. You combine steps 2 and 3. So the second step is where you just replace the letters with the numbers, and then the last step is when you solve. You just erase, the last step is when you solve this. So this is a D. This is step 1, write the equation. This is step 2. Step 3 is where you solve this. D equals 20 divided by 4. D equals 5 grams per milliliters cubed. You just combine steps 2 and 3 in one step. Okay? Okay, on the back of that, I'm going to go ahead and show you, that's where we stop with the notes. Okay? But on the back, I'm going to go ahead and show you what to highlight, but I don't want you to fill in the blanks yet. We're going to do that in the notes part here in just a minute. Okay? You're going to highlight these 3 things. Basically the 3 bullet points, the first 3 bullet points. It will end up being conductor, insulator, and mixture, but don't fill them in yet. Just highlight them. Okay? Then, once you have that, you can stay right there. Take out your pencil, because we're going to get right to those notes. No. Well, put the water bottle on the floor. Like a drum roll over there. All right. Cool. Okay, here we go. We have talked about many, many, many physical properties. Okay. Now we're going to specifically talk about the last 2. Okay. The first one is electrical conductivity, which is a lot of syllables basically describing will it or will it not conduct electricity. Okay. You can think about it like a circuit. If you put the object in the circuit, will it cause the electricity to flow or will it not? Electrical conductivity is how well a substance allows electricity to flow through it. Okay? For example, a metal is a great conductor. That's why most of our pots and pans are made out of metal. When you put the food in the pan and then put the pan on the stove, the metal will transfer the heat from the stove to your food to cook it, or to the water to boil it. Okay? Metal is a great conductor. It's also why it's what makes up our electrical wiring. The reason why the plug in the wall conducts electricity to my computer to charge it and power it is because the metal wires on the inside conduct or carry electricity to it. Okay? That's a good conductor. An insulator is the opposite. An insulator is a material that does not allow electricity to flow easily through it. Okay? For example, paper. If my electrical wires were made of paper, my computer would never charge. Okay? They do not transfer energy to the object. Rubber is a great insulator. This is why one of the safest places to be during a lightning storm is in your car. Okay? Because the tires on your car are insulators. If the lightning were to, by chance, hit your car, okay, it would travel through the metal pieces of the car, but then stop at the rubber wheels. Okay, and it wouldn't come into the car or shock you. The rubber does, it's called, it grounds the lightning. Okay? It travels through the car and then stops. The rubber causes it to stop. Okay? It does not transfer at all. As well as plastic. Okay? If I put my food in plastic and then put it on the stove, it's not going to heat up very well. Okay? Plastic is not a good conductor. Yes?
So, are guns electrical?
Are guns electrical? No. Okay? last thing about insulator. Raise your hand if you've been in your attic before. You know all that pink, fluffy fiberglass stuff? Okay. Looks like this. Oops. This. Okay. This is a picture of a guy installing insulation in the walls of the building. Okay. Now, the purpose of that is this. Okay. The insulation does not conduct the electricity inside or outside. So, a couple of days ago when it was 30 degrees outside and it was 70 in our room, if the walls didn't have insulation, the heat from this room would conduct outside very quickly. And it'd be freezing in here. Okay? On the flip side, in the summer, when it's 100 degrees outside but 70 in here, the insulation keeps the heat from traveling into the room and heating us up. Does that make sense? Okay? The insulation keeps temperature the same because it doesn't conduct the heat either way. Make sense? Okay? That's the purpose of the insulation in your house. Now, the last piece of properties is whether or not the matter, when combined with something else, will it become either a mixture or a solution? So you got conductor. This one's insulator. Luke?
In my neighborhood, his younger brother, when he went in the attic with his friends, he thought the stuff was
Oh no. That's terrible.
And he jumped in.
You jumped in. Yay! Alright, so last property of matter, or physical property that we're going to look at, is whether or not it will either make a mixture or solution when combined with something else. So, what does that mean? A mixture is a combination of two or more substances where each of them keep their own properties and can be easily separated. A good example is trail mix. Okay? Trail mix is a mixture. There are lots of pieces in trail mix. But when you mix it up, they don't dissolve into each other. Okay? I can still see the individual pieces. I could even separate it back out if I wanted to. I could pick out all the peanuts. I could pick out all the M&Ms. I could pick out all the almonds, all the raisins, etc. Okay? A solution is different. A solution is when you combine the two ingredients and one of them dissolves into the other, like chocolate milk. Okay? Take the milk and the chocolate powder, you dump it in, you stir it up, and it's all dissolved into it. Okay? When that happens, you can't really go back in and pick out the chocolate. Okay? It's dissolved. That's a solution. Okay? And the ingredient is just a single part of either one. There are however many ingredients here, 2 ingredients here. Okay? Now, somewhat of a trick question. Salt water. Okay, so water with salt dissolved into it. Is that a mixture or a solution? Layla? Good. Technically, by definition, it's a solution. But because only because the salt dissolved into it. But because you can take it apart again, it is like a mixture. Okay? If you boil the water or allow the water to evaporate, the salt left behind would separate the 2 pieces. Okay? Ian.
You can use
either one. Yeah, you can use syrup too. Okay. Hold on, I can't take questions right now because we're gonna run out of time if I'm not careful. Alright, now we're gonna go on to note number 4 and quickly look at physical and chemical changes. Here it is. Okay. So, we have talked so far about physical properties. Ingredients. Okay? Layla? Yes. Oh no, sorry, it's already highlighted on a different page. You don't need it twice. It's on the other one, the solvent, dissolve, all that. No. Okay? Alright. So, physical properties. Anything you can observe or describe about the object. For example, this object here. I can observe its physical properties. I can measure its mass without changing it. I can measure its volume without changing it. I can measure its color. I can tell you its color without changing it. I can see its shape without changing it. All of those are physical properties. Chemical properties, however, are properties you can only observe as the object goes through a chemical reaction of some sort. Okay? Which would change the substance. It will change the atomic structure of the object. Okay? So, by definition, chemical property is any of a material's properties that become evident during a chemical reaction. This is the first part of your notes. Any of a material's properties that becomes evident during a chemical reaction. Now, because it is reacting with something else, it creates something that is irreversible. Once you cause that change, it cannot go back to what it was before. Okay? For example, burning something. If I take the orange and burn it up to observe its burning capabilities or its flammability. Brian, what's up? Huh? I don't think you got 4 already, bud. You have 3. That one's 4. If you burn something up, you can't get back what you had before, right? If I burn the orange, I can't go back to having the orange already. Okay? Chemical reactions are another example. If I mix the orange with other chemicals and cause some kind of reaction to where it dissolves or it bubbles up or it burns up or changes into something else, it no longer is an orange, but it's something else. Okay? So, to observe the chemical properties of anything, it has to go through some sort of chemical reaction. So, there are less chemical properties than physical properties, I would say. We're also only going to go over 3 of them right now. We're going to kind of go fast. The first chemical property we're going to look at is the heat of combustion. The heat of combustion. Caleb, did you miss some? The heat of combustion. The heat of combustion is the amount of energy given off when an object combusts or blows up. Okay? Gunpowder is a good example. Gunpowder, when you burn it, eventually it blows, right? And produces a big boom. Lots of heat, lots of energy comes out. That has a high heat of combustion. Paper, on the other hand, if I burn paper, it gives off some heat, some energy, but it will not produce nearly as big of a boom as gunpowder does. You see what I'm saying? Okay? Paper has a smaller heat of combustion. Gunpowder has a bigger heat of combustion. Layla? Huh? All right. Caleb, when you get caught up, can you pass it to Layla, please? Okay. So, that's one chemical property. It's heat of combustion. Can only be observed when you put it through heat or burning. Boys, turn around. Second one, chemical stability. Turn all the way around. Whether or not a compound will react with water or air. There are some substances that are so unstable that they will actually cause a reaction just with oxygen or with water. Think about an apple, for example. When you cut an apple open and leave it on the counter, what happens to it? It turns brown. Okay? That's called oxidizing. That's a chemical reaction between the acid in the apple and the oxygen in the air. Okay? There are metals that oxidize with oxygen. Okay? One very unstable chemical is sodium. Now, sodium is commonly used to refer to salt. All right, like the sodium levels of your food. However, salt is actually sodium chloride, not pure sodium. Okay? Pure sodium is a metal, like a chunk of metal. Jacob, hush. Pure sodium, the metal, when it combines with water, produces a reaction, a big reaction, which I'll show you here in a little bit. Last one we're going to do is flammability. Whether or not the compound will burn when exposed to a flame. The only way to find out if a substance is flammable is to light it on fire. Okay? Gold is not really flammable. It will not burn if you expose it to fire. It'll melt, but it's not necessarily going to burn. Paper, highly flammable. Okay? When exposed to fire, the paper will burn. Brian?
Isn't alcohol flammable?
Alcohol is very flammable. Yes. Ian? Combustion. Connor? It's a video, but yeah. Ian? Okay, heat of combustion. Energy released when a compound combusts from heat. Aiden?